Hello viewers, welcome back to the course on matrix computation and its application. So in the previous lecture we have discussed the very important theorem about the singular value decomposition of a given matrix. So today in this lecture I will do some, we'll take the help of MATLAB or Octave, and then we'll see that how we can find out the singular value decomposition of a given matrix. So in the previous lecture, if you see, then we are able to take the singular value decomposition for the given matrix, and then we have found the value of the matrix V, and then we found the value of matrix U, and then using this Gram-Schmidt process we are able to find U3, but this U3 I can find with the help of the linear algebra. What I can do is that, so I have a matrix, we have started with the matrix 1 1 0 1 1 0. So this is my matrix, and then we find the value of U1 and U2 that belongs to the column space of A. And we also know that the column space of A, so this is my column space of A and this is my null space of A transpose, and they are orthogonal to each other. So I can say that my U3 I can choose from null space of A transpose, and that will be perpendicular to this one. So this one I can find from, so now I can take the A transpose. So A transpose will be, this is 1 0 1 1 1 0, and I am taking from here, so its value will be x y z, and it should be 0 0 0. And from here you will see that I will get x plus z equal to 0 and x plus y equal to 0. And both the things gives you y is equal to z, because if I take this minus this, so g to be z minus y equal to 0, so y equal to z, and from here I can get my x as minus of z, or I can have x is minus of y. Now from here I can choose my vector U3 as my y and z should be same and x should be minus of that. So suppose I take here 1 1 and it should be minus 1, and then I have to normalize, so I will divide by root 3. So this is, I get the U3. So the same U3 I have taken here, so that is also we can find out within a Gram-Schmidt process, but we can do this by this way also. So now we are able to find my U3. So let us start that how we can verify that whatever we have done is right or wrong. So let us take the help of Octave. Now in Octave I just start with the matrix A. So this matrix I am writing, so I am writing here 1 1 and then 0 1 and then I am taking 1 0. So this is my matrix. You can see from here that I can find the rank of this matrix A. So this rank is 2. Now from here I can find out the value of A transpose A. So this is my matrix. So I have to write here star multiplication. So this is my matrix A transpose A. Now I can find the eigenvalues of A transpose A and the corresponding eigenvector also. So I will write one, so I will V and I find its diagonal matrix D. So, I write this is equal to EIG, eigenvalue of my answer. So, whatever the answer I got. So, by using this one I can find the eigenvalues and the corresponding the matrix made up of eigenvectors. So, if you see from here, this is my eigenvalues 1 and 3, and this is the corresponding eigenvector, and we also found the eigenvector for V1 I got 1 by square root 2. So, if you see, if I find 1 by square root of 2, so I get 0.701. So, I got this value. It means that the eigenvalue of is 3 and the corresponding eigenvector is 1 by root 2 and 1 by root 2, and corresponding to 1 eigenvalue, the eigenvector is minus 1 by root 2 and 1 by root 2. So, this one we can take. So, the same thing we got, if you see from here, I got this value. So, here V2 we have taken minus sign here, but in this we got this minus sign and this one. So, that does not matter. So, we can also take minus sign here. Okay, so, this way we can find out. So, this is okay because this value is equal to same 0.707, that one I can write only 0.707 because it will give you the numerical value only. So, this is the way we are able to find the value of V, and this is the value of D. Now, I need to find the value of U. So, I told you that let us see what is going to happen if I take A star A transpose. So, this is my matrix 3 by 3 matrix, and if I want to find the eigenvalue of this, then you will see that its eigenvalue will be 0, 1 and 3, because it is of order 3 by 3. So, eigenvalues for A transpose A is 3, 1. So, in that case we will get the 0 eigenvalue more, and now I can write down these things and I can write from here. So, now I can diagonalize this value, this matrix. So, I will write my U here, U, and then maybe I can write D1 and that is equal to, I write eigen of A star A transpose. So, this is the values I got. So, now from here you can see that matrix is this one. So, for the corresponding eigenvalue, 3 eigenvalue I get this vector, and this vector is 0.4, 0.4 and 0.8, and if you see from here I got the value of U is, first U I got this value 2 by root 6, 1 by root 6, 1 by root 6. So, if you see from here, I just check what is the 1 by root square root of 6. So, 0.4. So, it means it is 0.4, it is 0.4 and is 2 times 0.4. So, I got the value of this vector, this value. Then another one I should get my U2. So, U2 is 0 and this value. So, let us see what is here. So, here also this is minus 17 means its value is 0, otherwise it is minus 1 by root 2 and this is plus 1 by root 2 corresponding to 1, and the last value we have found, this one is minus 1 by root 3, and if you see from here, that is corresponding to 0 eigenvalue, and this is my 0.5. So, if I take 1 by square root of 3, So, this is the value 0.57 and I got this value here 0.57 here. So, in this case I got this value, and so now we are sure that whatever the calculation we have done for finding these values of u and v, they are right. Now, there is a one command directly for finding the SVD. Now, from here if you see, let us check what is going to happen if I multiply u. So, this is the u I got, u star. Now, sigma I have to take. So, sigma is, as I told you that sigma is the matrix. So, I just write, let us I define sigma A. So, that matrix will be, so lambda 1 and lambda 1 is 3. So, I can write from here that it will be equal to square root 3 and then 0. After that I can write here 0 and 1, and it should be of the same dimension. So, I can write from here it should be 0 and then 0. So, this is my sigma A. So, now if I take u multiply by sigma A and multiply by the v I have taken. So, I just take the transpose and let us see what is going to happen. So, this is, so now I have to find my A, we got u, this is my v I got, and I got this value, it is 3 cross 2. So, let us see, I will write SVD. So, this is the direct command I can have. So, I can just check by this way. So, I can write my u here, then sigma I just by s, and then I will write v and I put SVD of the matrix A. So, here I can directly I can write. So, now from here I got my u. So, let us see whether u is going to be same or not. So, this is my u and I think I got the same u, only change in signs. So, this sign actually it changes because we take the sign depending upon the orthogonality, and sometimes this change of sign will, when multiplied, it gives the different results as we are getting in this. But other things you will see that it is going to be the same. So, u value u is same as this u is minus 8 minus 4 minus 4, and we have seen that u is 844. So, just we have taken the negative sign. Other things, diagonal element matrix I already told you it will be 1.7 root 3 1 0, and v is same as we have taken. So, minus minus, so it is coming here, this is, so in this case it should be minus minus and it should be plus minus. So, that is there, it is minus minus and plus minus. So, negative of that one they have taken. So, let us see that now if we, so my u and v has changed now. So, my u is, I will take this multiply by s and multiply by v transpose, and I get this value. So, this is the same matrix that we got 1 1 0 1 1 0. So, that is the same value we have got. Here I was getting something different, because now we have to take care about the sign of the vectors. So, sometimes if you do that one, you get some different values of the solution, and that is what is happening in this case. But otherwise everything is completely right, except that the some change in signs. So, these things we can do. Now, we can apply some other examples and see that how we can do the SVD for other matrices. Now, let us take another matrices. So, I just write clear all. So, it will clear. Now, I can define my some different matrix. Suppose I take the matrix A and I just take it, maybe I just take matrix 1, 1, 2, 3, and then I will take 0, 1, 2. So, let us take this matrix. It is 2 cross 3 matrix. Now, I want to find about what is going to happen in this case if I take the S. So, just I take U and then I will write S, and then I will take V and I will write is equal to SVD of the matrix A. So, this is my matrix. Now, my U is 2 cross 2, V is 3 cross 3, and its eigenvalues, if you see from here, then I just write A, I just find, let us see what is going to happen. So, I just write, I take, maybe I will write corresponding to A transpose A. So, I write VT, VT means V corresponding to transpose, and DT, I just write that one, and this one equal to, I write eigenvalues of A transpose star A. So, let us see what is going to happen here. So, this is my A transpose A, that is 3 cross 3 matrix. Of course, it will be 3 cross 3, and this is the 3 eigenvalues. So, it is 1.8 10 to the power 1, so 1.18, and this is 0.3 and this is 0. So, one eigenvalue is 0 because the rank is 2. If you see the matrix A, its rank is 2. So, one eigenvalue has to be 0 in this case, as it was 0 in the previous case for U. So, one eigenvalue should be 0, and this is the value we got. Now, it's the same thing I can check for U. So, let us see what I get for U, and maybe I can write as D1, and this is A transpose. Oh, I get this value, this one. So, it will be 2 cross 2, and the eigenvalue will be same 0.32 and 18, and this is my corresponding matrix. So, now in this case also, if you see, the everything is written differently. Yeah, so in the previous case, if you see the U and V, now if you see from here, the U we have written here in this fashion, and the eigenvalues are given to us with the ordering, that it is the maximum order, then the smallest one. But if you see from here, taking A transpose A, in this case the eigenvalues are written in the, that this is a 0, then it is 0.32 and this one. So, that is why in the previous case when we multiplied, it was changing the order. Similar case is here. it is 0.3 and 0.18. So, that is why we have to keep in same order that highest power and the lowest power. So, that is why if you see in the previous example we were not able to get the same eigenvalue or same matrix, but here we are able to do that. So, now from here you can see that now if I take my u multiply by S and then multiply by V transpose, I get this matrix, that is 1, 2, 3 and 0, 1, 2. So, this is the matrix I have started with, this is. So, we got the same matrix using this value. Now, so let us see that what went wrong in the previous example. So, let us see that one, because now we are able to see that why it was not coming. So, let us take A is same as the previous one, it was 1, 1 and then 0, 1 and then 1, 0. Then we found our value of u, that. So, I will take this here. So, we got the value of, first I will write down the value of V1 and V2. So, V1 and V2 is this one, I will write like this one. So, let us now I take V is equal to, V1 is 1 by square root 2 and let us copy it, because the same value I have to write. This is the control C. Now, I will write here control V. So, this is, and so this is our first one, 1 by root 2, 1 by root 2 and this is again 1 by root 2 minus 1 by root 2. So, I can write control V and minus sign control V. So, this matrix I got, this is my V. So, this is the V we have taken. Now, I will write down my sigma. So, sigma we have taken sigma of A. So, that is equal to, I can write, so it was square root of 3, then its value was 0, then its value is 0 and then 1 and then its value was 0, 0, because it should be of order 3 cross 2. This is my sigma and u we have taken. So, my u was, now we should write u this one, 2 by root 6, 1 by root 6. Let us see what is going to happen here. So, first I will write 2 by square root 6 and now I will copy this one. Control C. So, this one I will just write, it is 1 here, it is 1 here. So, this is the first one. Then the second one is, in this case it is 0 minus 1 by root 2, 1 by root 2. 0 minus 1 by 2 and 1 by square root 2. So, this is the second one, and the third one, if you see, this was 1 minus 1 by root 3 and other things are same. So, I will take minus 1 by square root of 3, and this one I can take, I will copy, Control C. So, I will write down Control V, Control V. This is my u. No, we have to write as a column vector. So, I think we should write u as u transpose. Yeah, now it is okay. 0 minus this, yeah. So, that should be the u. So, I think v also we have to write. So, v should be also v transpose, yeah, this one, because see we have to write in the column, first column should be 2 by root square root 6, 2 by root 1 by root square and 1 by this one, then it is 0 minus 1 by root 2, 1 by root 2, and this is minus 1 by root 3, 1 by root 3, 1 by root 3. The similar is 1 by root 2, 1 by root 2, 1 by root 2 minus 1 by root 2. So, this is okay now. So, now we can take the multiplication u star, and then I will write sigma, I just write here in this, and then I take star and then v transpose. Now, we get this value. So, this matrix is same as our matrix A, 1 1 0 1 1 0. So, if you see now it is coming same. So, everything is okay in the previous example, whatever the example we have done in this case. So, it is verified now that we are getting this value. So, from here we are able to see that my u sigma v transpose, it is giving my A. So, whatever we have done is completely right. So, this way we can take any matrix. We have taken 2 by 3, we have taken 3 by 3 matrix. Maybe I can take some other matrix. Maybe I can take a very big matrix, that is I just take 0 1 2 3 5, and then so this is my first row, and maybe I can take the second row as 0 0 1 1 1 second row, and in the third row I can take 0 1 0 1 0. So, this matrix I have taken. So, it is 3 cross 5 matrix. So, this matrix we have taken. Now, I can find out is SVD directly. So, this is U S V, I can write down as SVD of the matrix capital A, and this is the corresponding SVD. Now, you can see that my U is 3 cross 3 and diagonal matrix is now 3 cross 5. So, it was 3 cross 5. So, 3 cross 5. So, this is my corresponding singular values, the largest one and then the next and the next, and this is my corresponding V. So, in this case A transpose A is a 5 cross 5 matrix and it is going to have 5 eigenvalues. So, 2 eigenvalue be 0, because in this case if you see the rank of A is 3, and if I want to find the eigenvalues of A transpose star A, so it will be 0 0 and 0.4, 1.5 and 42. So, you can see from here. So, it is a 5 eigenvalue and 2 eigenvalue be 0. So, the remaining eigenvalue, so that we have seen that this will be the 3 eigenvectors that is non-zero and 2 eigenvector will be 0, and then from here we can find the eigenvalues. Similarly, I can find the check the eigenvalues of A star A transpose star, and this eigenvalue is the same except the 0 0. So, there is no 0 0 eigenvalue there, and then we can find the value of corresponding eigenvectors, and then if you see, then this is my u, s and v directly I can take with the help of inbuilt function in the MATLAB or Octave, and that it gives me the SVD. And you can also verify by solving on with the pen and paper, and then you can do the multiplication in this case. So, you will also be able to get the same result. So, this is the way actually we can find out the SVD for a various matrices with the help of Octave. So, now we will stop here. So, in the today's lecture we have just taken the help of MATLAB or Octave to verify that whatever the calculation we have done to find out the singular value decomposition is whether right or wrong, and we found that whatever the multiplication, whatever the calculation we have done is quite right, and then we have compared it with the inbuilt function, that is SVD function, and we found that both the cases we are getting the same result. So, you can just, it is just the introduction that how we can manipulate with the help of Octave, and you can play with this one and you can find out the SVD or the eigenvalues of different type of matrices you can take, and then you can verify the results for a given matrix to find the SVD. So, I hope that you enjoyed this lecture. Thanks for watching.